Okay, so the next thing that I want to tell you is about some references. So it's always good to have good references in hand, a textbook, for example. And nowadays there are so many things available, especially in this area of computer simulation. It is often difficult to choose one. So I want to leave you with two textbooks that I recommend. So one of them is about statics, and you may think, well, this course is about dynamics. But the reason why I am recommending that specific book, the statics edition, is because it lays the foundations in continuum mechanics that is key for, for computational mechanics in general. So that's the reason why I recommend that book. And then, of course, the dynamic is totally related to what we are talking about in this course. So other resources to be familiar with. So first of all, the user's guide of your software. Whatever software you're using, it probably has a user's guide and eventually even a theory manual. So reading through those materials can be very enlightening, will really enhance your understanding about the software, about the theory, and mostly important, will make you understand what are the capabilities and the limitations of the software that you are using. So it's really important to understand where your software can perform well and where it can perform badly. So if there are some known cases where the software is not applicable, it's very important that you know what are those cases. So another thing important about the users' guides is that they often come with lots of bibliographic references, so you can cross-check those references. I am recommending here some high-impact scientific journals. So I put a couple of them in the slides, like CMAMI or the International Journal in Numerical Methods in Engineering, Computational Mechanics, Computer and Structures, and many others. So the reason why I'm recommending this is because I would like you to be up to date with the state of the art in the field. So when you read recent papers, so recent academic research that is being developed in the area, you will have an overview of what is coming next to your commercial software. You will be looking for what people are doing in academic research, so that those techniques may still not be available in your computational software, in your commercial software, but at some point they may be. And most important is to see what those academics are saying about the limitations in the field. So in those papers there will be often a couple of benchmark problems and test cases that you can use to understand what are the capabilities of your software. So if you get to read a paper where people are saying that the current technology doesn't perform well in a specific problem, you could try your software to solve that specific problem to understand how badly it behaves. So that's an interesting thing, because as I said before, it's really important to know what are the limitations of the tool that you have in hand. And you can also use problems and benchmarks presented in scientific papers as verification or even validation test cases for your own studies. So it's often the case that people publish experimental results, and you can try to reproduce those using your software. And of course, I do recommend using online resources such as lectures, courses, tutorials, etc. Just be critical. It's very common to see content where people are only teaching you how to press the buttons in a software and generate some colorful figure or animation. But we should always be based on some foundational knowledge and understand what we are doing, and if what we are doing is correct. And so don't be deluded by beautiful figures. Try to learn how to use software, but always understanding the underlying theory, the theoretical background needed to solve the real problems of engineering.